Hello everyone, here's my enzyme model that I have. So this purple one right here, this is the enzyme and here's the substrate. Now I will just walk you through what I have going on here. So here it bonds, and then here the enzyme takes care of its job. It speeds up the reaction. The substrate then breaks off and then goes away because the job is finished. Okay, so if we just focus on this one part right here, this right here is the active site. This is where the substrate comes in and bonds and makes the enzyme substrate complex. Now we're going to talk about the activation energy. Activation energy is just basically the amount of energy needed to start off a reaction. So in this case, our enzyme is the catalyst that speeds up, makes energy go up. So this right here that I have in my hand, this little square, is the inhibitor. This is a molecule that binds to an enzyme to either lower or stop reaction. There are two that we need to talk about today. The first one is the competitive inhibition. This is where it would get in the way of the substrate, so it would come in here and just block away to where this couldn't come in. And then next we have the non-competitive inhibition, which is where this can still come in, but this would come in from this side or another side and just slow down the reaction. So just to summarize, the competitive stops the binding, and then the non-competitive just slows down our reaction. Okay, so all of this happens in an allosteric site. This is a site that differs from the active site, so probably down here, I would say. And this, we also need to talk about the allosteric regulation. This is when an inhibitor molecule binds at a specific regulatory site, so right here, we'll just say, and they either enhance or reduce enzyme activity. The enzymes that have this are sometimes called allosteric enzymes. Okay, now we're going to be talking about what will happen if the pH is altered. So enzymes need to function in a pH balanced area. So if the pH is altered, basically what will happen is that it will slow the enzyme down. However, if the pH is way out of range for the enzyme will just denature and it won't function. And then we need to talk about if the temperature lowers. So if the temperature goes down, the enzyme will just, oh no. All right, so finally, what will happen if the enzyme is in a low temperature? They will just simply become inactive. So just think of the enzyme going to sleep, and that's basically it, because it cannot function if the temperature is not at a good, stable temperature for the enzyme. So thank you so much for watching, and I hope you have a good day, and don't forget to comment. Okay, bye.